Hi there. This is going to be lesson 6.3 in our math book. So first we're going to just review some different ways of how we can represent word problems. So this first word problem, we're going to read it, and I want you to think, is this an add to problem, a take away problem, or a put together or take apart problem? So let's read it. So it says, Aisha made 15 friendship bracelets. 6 were pink and the rest were blue. How many blue bracelets did Aisha make? Okay, so let's see. So she made 15 friendship bracelets. That sounds a lot like a total to me. 6 were pink and the rest were blue. Okay, so it gives me one of my add-ins and my total. So this is an unknown add-in problem. Okay, so let's think of some ways that we can represent this problem. We know the math mountain way. So if we're doing a math mountain, where does our total go? Up at the top, right? So she had a total of 15. And then where do our add-ins go? On the edges, or on the ends here. So one of our add-ins were the 6 pink bracelets. The other add-in is going to be the blue bracelets. So we'll put a box there, just to kind of leave it blank for now. But if we figure that out, we know that 15 minus 6 is going to be 9. So 9 blue bracelets. Some other ways that you can represent this problem is by using math sentences or equations. So one way we could do that, we could do 15 equals, we've got our total here, 15 equals 6 plus, and we can put a variable here. So I'm going to put the variable B to stand for blue, for the blue bracelets, because that's what we're trying to figure out, how many blue bracelets she made. Okay, so that's one way that we could also represent that. We could also do, our total minus one of our add-ins. So we could do 15 minus 6 equals our variable B for blue bracelets. Or we could also do 6 plus our variable B equals 15. So as you can see, there are many different ways of how you could represent your word problem so that you can solve for that unknown add-in. All right, now let's practice representing a different type of problem in different ways. So let's read this first. It says, Faith had 13 stuffed animals. She gave some of them to her sister. Now Faith has 5 stuffed animals. How many did she give to her sister? So I want you to take a second to think about what type of problem this is. Look for those key words that'll give you some clues. So the first key word that I see is this word some. So remember when I said that some is a clue of what kind of problem it would be? So some is a clue that this is an unknown add-in problem, but it sounds like it's not an add to problem because she's not getting more of something. It seems to me like this is a takeaway problem because she's taken some of those stuffed animals away and giving them to her sister. So let's represent this problem in some different ways. Let's start with our math mountain again. So I'm going to make my math mountain here. And what number goes at the top? Our total. So I'm going to read through my problem again and try to find where it tells me my total. So Faith has 13 stuffed animals. That sounds like a total to me. So I'm going to put the 13 stuffed animals at the top. And that's how many she had, right? So I'm going to label that she had 13 of those. That's what that says, had. It's kind of small, sorry. Now, what other information does the problem give us? It tells us that she gave some of them away, but now she has 5 stuffed animals. So that sounds like one of my add-ins. Where do my add-ins go? At the ends of our math mountain. So I'm going to put my 5 here, which is how many she has now. Okay, and then here, I know this is going to be the number that she gave away. So, what plus 5 would equal 13? Or, another way to think of it, we could say 13 minus 5 equals what? It equals 8. So, she gave her sister 8 of those stuffed animals. Now, let's practice putting these numbers into different math equations or math sentences. One way that we could do that is we could do the total minus, I'm going to use the variable, not B. I'm not going to use B again. Let's see. I'm going to use the variable S for sister to kind of represent what she gave to her sister. So 13 minus S equals what? Equals how many she has left. So equals 5. Another way that we could represent it would be 5 plus our variable S for how many she gave to her sister equals our total of 13. Another way we could represent it is we could start with our total, 13 equals 5 plus our variable S that we need to solve for. Or we could do 13 minus 5 equals our variable S. Okay? So those are some different ways of how you can represent take away unknown add-in word problem. So today you are going to be doing some problems that are known as unknown start problems. So what I want you to do, as I'm reading this problem, I want you to be thinking about why is it called an unknown start problem? Okay? Think about that. Why is it called unknown start? So Greta puts some beads on a string. Then she puts on 70 more beads. Now there are 130 beads on the string. How many beads did she put on to start? So why do you think that's called an unknown start problem? Because we don't know how many beads she started with on the string. So it's pretty well named because we don't know the start. So it's an unknown start problem. All right, so let's talk about how we can represent this problem in a couple of different ways. So if we don't know the start, we could just put a little box there, kind of like our blank, our unknown start. So our start, and then she added 70 more beads. She put 70 more beads onto the string. So we're adding 70 beads to get a total. So now there are 130 beads on the string. So that's one way we could do it. We could do blank plus 70 equals 130. Another way that we could represent that is, instead of doing addition, we'll just do the inverse. We'll do subtraction. So we're going to do our total number of beads, 130, minus the 70 equals however many beads she started with. So that's our unknown start that goes in that box right there. We could also do one of our lovely math mountains. So we know that the total number of beads that she ended up with on the string was 130. We know that one of the add-ins is 70, those 70 beads that she added on. And we want to know how many beads she started with. So we could do our little box there. So if we know that 13 minus 7 is 6, we also know that 130 minus 70 would be 60. So our answer would be 60 beads. That's how many she started with. All right, so some of the problems in your math book also ask you to write a situation equation and a solution equation. So let's do an example of one of those together. So first, the problem says 8 vans with the same number of students in each van took 40 students to the Science Center for a field trip. How many students were in each van? So first I want you to think about what kind of operation does this question sound like? Does it sound like addition, subtraction, multiplication, or division? So think about that for a second. Pause the video if you need to. So there are some clue words that give me a hint of what kind of equation we're going to use here. So this here where it says the same number of students in each van, that is telling me that there are equal groups. And if there are equal groups, what is that telling us? It's either multiplication or division. And as we see from our previous problems that we've done, we could solve this problem using either one. So first, I'm going to write a situation equation. So if there are 40 students going to the Science Center on these buses, or on the vans, and there are 8 of those vans, I can say, or I can write an equation that looks something like, so I have 8 groups, those are my vans. I want to know how many are in each group, so I'm going to put a variable here. I'm going to do S for students, so 8 times S equals our total number of students, which is 40. So I'm going to write that as my situation equation. Now this might be the equation that you use to find your solution as well, and that's great. But I'm going to try to think of another equation that I could use. So if 8 times S equals 40, I could do the inverse operation of division and do 40 divided by 8 equals S. And so now if I do 40 divided by 8, you could do count bys by 8, you could do 8, 16, 24 until you get to 40. Or if you know it in your head, 8 times what equals 40, you find your solution of 5 students. So there are 5 students per van, because 40 divided by 8 equals 5, and 8 times 5 equals 40. So there's that for you. All right, so that's it for this lesson. If you have any questions, make sure that you ask your teacher. You can email me, you can chat with me on Zoom or anything like that, and I hope this helps.